Modern cars are packed with more technology than ever before, yet they're breaking down at rates that would shock drivers from 20 years ago. The average car from 2020 has more issues in its first 3 years than a car from 2000 had in its first 10 years. This isn't opinion. This is data from independent reliability studies and repair statistics that show a disturbing trend in automotive manufacturing. What's causing brand new vehicles to fail faster than the supposedly less advanced cars from decades past? The answer involves planned obsolescence, cost-cutting measures, and engineering decisions that prioritize short-term profits over long-term durability. As someone who's worked in automotive repair and seen this evolution firsthand, I can tell you exactly what's changed in modern car manufacturing that's making vehicles less reliable. The truth is going to make you think twice about trading in that older reliable car for something newer. Keep watching, because understanding why new cars break faster will help you make smarter buying decisions and potentially save you thousands in repair costs. Hey, if you like this kind of straight-to-the-point content with no BS, help me out here. Subscribe to the channel right now. It takes 2 seconds and guarantees you won't miss any tips that could save you some serious cash. Let me start with some hard data that proves this trend is real. According to Consumer Reports reliability surveys from 2023, the average new car experiences significant problems within the first 3 years at a rate 40% higher than vehicles from the early 2000s. JD. Power Initial Quality Study shows that problems per 100 vehicles have actually increased over the past decade, despite all the technological advances. RepairPal data indicates that the average repair cost for vehicles 3 to 5 years old has increased by 65% when adjusted for inflation compared to similar aged vehicles from 2005. These aren't just minor issues either. We're talking about transmission failures, engine problems, electrical system malfunctions, and infotainment system crashes happening on cars with less than 50,000 miles. My own shop has seen a dramatic increase in major component failures on newer vehicles. 10 years ago, it was rare to see a transmission fail before 100,000 miles. Now I see transmissions needing replacement at 60 or 70,000 miles on vehicles that are only 4 or 5 years old. The question everyone asks is why? If modern engineering is so advanced, if computers control everything, if manufacturing tolerances are tighter than ever, why are new cars less reliable than older ones? The answer is complex and involves multiple factors across the automotive industry. First major factor is the massive increase in complexity. A car from 1990 had maybe 20 electronic control units managing various systems. A modern car from 2023 has over 100 electronic control units. Each one of those is a potential failure point. Your car now has computers controlling everything from the engine and transmission to the seat position memory and ambient lighting. More components mean more things that can break, and these aren't simple mechanical parts that can be easily fixed. When an electronic control module fails, you're often looking at a $500 to $1,500 replacement cost for a single component. The integration of all these systems also means that when one thing fails, it can cascade into multiple problems. I've seen cases where a failed body control module caused the entire electrical system to go haywire, triggering false warnings, disabling features, and requiring thousands of dollars in diagnostics and repairs. Second major factor is planned obsolescence and cost optimization in manufacturing. Modern automotive companies are under tremendous pressure from shareholders to maximize profits every quarter. One way they do this is by engineering components to last just long enough to get past the warranty period, but not much longer. This isn't conspiracy theory. This is documented practice in the industry called value engineering. For example, older automatic transmissions used to be built with robust mechanical components designed for 200,000 miles or more. Modern transmissions, especially CVTs and dual clutch designs, use lighter materials and tighter tolerances that reduce manufacturing costs, but also reduce longevity. The result is transmissions that work smoothly for the first 60 to 80,000 miles, but then start having issues. By the time major problems occur, the vehicle is often out of warranty and the owner is stuck with a $4,000 to $6,000 repair bill. Another example is the use of plastic components in critical systems where metal used to be standard. Engine timing chain guides, water pump impellers, intake manifolds, thermostat housings. All of these are now commonly made from plastic on modern engines. Plastic is cheaper and lighter than metal, which helps with manufacturing costs and fuel economy. But plastic degrades over time from heat cycling and exposure to chemicals. Components that used to last the life of the vehicle now need replacement at 80 to 100,000 miles. I've replaced more plastic intake manifolds cracked from heat stress in the past 5 years than I did in the previous 15 years combined. Third factor is the push for extreme fuel economy and emission standards. Don't get me wrong, cleaner, more efficient cars are good for the environment, but the engineering required to squeeze every last mile per gallon out of an engine while meeting strict emissions standards has led to some reliability compromises. Modern engines run hotter, have tighter tolerances, use thinner oils, and employ complex emissions control systems that are prone to failure. Gasoline direct injection systems, which are now standard on most new cars, have major carbon buildup issues that didn't exist with traditional port injection. Turbochargers, now common even on small four-cylinder engines, add heat and stress that reduces engine longevity. Variable valve timing systems, while great for performance and efficiency, have numerous small components and solenoids that can fail. The result is engines that perform better when new but require more maintenance and have more potential failure points than simpler engines from previous decades. Fourth factor is the quality of materials and assembly processes. To cut costs, manufacturers have increasingly moved production to lower-cost regions and suppliers. While this reduces the price of new vehicles, it also sometimes reduces quality control. I've seen more issues with poor paint application, inconsistent panel gaps, and substandard component assembly on newer vehicles than I ever saw on older ones. Additionally, the just-in-time manufacturing philosophy means that suppliers are constantly pressured to deliver parts faster and cheaper. This can result in quality compromises that wouldn't have been acceptable 20 years ago. The focus on reducing per unit cost means that manufacturers sometimes choose the cheapest supplier, rather than the most reliable one. This race to the bottom in pricing affects everything from interior trim pieces that break easily to critical engine components that fail prematurely. Fifth factor is software and electronics reliability. Modern vehicles are essentially computers on wheels. The infotainment system alone can have millions of lines of code. Unlike mechanical components that either work or don't work, software can have bugs, glitches, and compatibility issues that manifest in unpredictable ways. Over-the-air updates, while convenient, also mean that a software patch can inadvertently cause new problems. I've had customers come in with vehicles that developed issues immediately after a manufacturer software update. Diagnosing software-related problems is often time-consuming and expensive, and sometimes the only solution is to wait for the manufacturer to release another update. Let me give you specific real-world examples. Honda, traditionally known for bulletproof reliability, has had major issues with their 1.5-liter turbocharged engine that's in the Civic, CR-V, and Accord. Oil dilution problems caused by fuel contamination have led to engine damage and recalls. This is a brand new engine design that has reliability issues that never would have made it past testing in previous decades. Ford's dual-clutch automatic transmission, used in the Focus and Fiesta from 2011 to 2016, was so problematic it resulted in class action lawsuits and cost the company hundreds of millions in settlements. Yet they continued selling vehicles with this transmission for years, despite knowing about the problems. Nissan's CVT transmissions have been notoriously unreliable across multiple model lines for over a decade. Failure rates are so high that extended warranties specifically for CVT replacement are now a common offering. These aren't small, unknown manufacturers. These are major brands with decades of engineering experience producing components that fail at unacceptable rates. So what can you do as a consumer to protect yourself from these reliability issues? First, research reliability data before buying any vehicle. Consumer Reports, J.D. Power, and RepairPal all publish comprehensive reliability ratings based on real owner experiences and repair data. Pay attention to specific problem areas for the models you're considering. Second, consider buying used vehicles from model years that have proven reliable over time. A 5-year-old car with good reliability history is often a better value than a brand new car with unknown issues that haven't been discovered yet. Third, if you buy new, seriously consider getting an extended warranty. I normally don't recommend extended warranties, but given the complexity and potential repair costs of modern vehicles, they're becoming more necessary as protection against expensive failures. Fourth, maintain your vehicle meticulously. Modern cars are less forgiving of skipped maintenance than older ones. Follow the manufacturer's schedule religiously. Fifth, keep your older reliable car if you have one. A well-maintained older vehicle with proven reliability is often worth more than its book value, simply because it doesn't have the complexity and failure points of newer models. The bottom line is that new cars are breaking faster than old ones due to increased complexity, cost-cutting measures, design choices that prioritize short-term performance over longevity, and the pressure to meet ever stricter fuel economy and emission standards. While new cars have better safety features and technology, they're not necessarily more reliable or durable than well-designed cars from previous decades. Understanding these issues helps you make informed decisions about what to buy and how to maintain it.